Awesome. Okay, so thank you. Yes, I love the trees too. That's one of my favorite parts of the office. It's going to be a shame in about just a few months, sometime this spring, this office isn't big enough to take in a full slew of students, so this is only going to be temporary as much as I love it. But today we are going to talk about using some functional programming. So specifically we're going to talk about the first half of the lecture. We're going to talk about split and join methods, and then after that we're going to get into some even more functional things, and we're going to go into how we can use the map method effectively, and I'm going to specifically address the difference between each and map, just so we can kind of solidify it, because I know when I was first learning Ruby I was confused because it seemed like each and map were very similar, and it took me a little while until I recognized the difference. And oh yes, and thank you, Silver. I absolutely love Arizona. It took me about 7 years to finally decide to move back, and I'm very happy I did. Okay, so let's talk a little bit before we get into the code part of the lecture. We're going to talk about split and join. Now these are two pretty similar methods in the way that they are written. However, they actually have the exact opposite kind of functionality. So split, the first thing that you should think of when you think of split is that split works with the string data type, and it is meant, it's very explicit, it is meant for splitting strings into their own elements in an array. So split, its goal is for splitting strings and splitting them up, and then it's organized into an array afterwards. And where this is really helpful is any time that you run into a situation where you need to grab certain elements or you need to perform some unique kind of actions on a set of elements, split is a great way of doing it, because it's very difficult to, say, create a string method that goes and selects the third word of every sentence and makes it capitalized, or whatever you want to do with it. Or if you think of a practical Rails example, what split could do is split is a way where you could grab just somebody's first name or just somebody's last name and display that, even if they gave you their full name. Split allows you to make a string something a little bit more manageable. So that's what split is, and we're going to get into some very cool examples on how you can use split beyond kind of the normal day-to-day operation that we've gone through so far. Now join's actually a little bit more basic than split. Join does not have as many options, and what join is specifically meant to do is to give you some tools for simply converting arrays to strings. So this one is going to work with the array data type, so it's going to work on a collection, and then it is, you can think of, if join is a method right here, join is going to take some kind of string that's going to get piped into join, and then when it comes out, then, I'm sorry, array. Had my arrows backwards. So this array of elements is going to go in, and join is going to be able to take that and then convert it into a string. And we'll talk about how we can do that practically. So now that we've kind of discussed those two, we're going to come back to a lecture spot when we go into talking about map in each. But now we're going to go into the code. So we're going to walk through some examples there. Okay, so here I have a file called functional, and I have all of our examples here so that I don't waste a bunch of time just typing things out from scratch. I'm going to copy them over, and then when we're done with this lecture, I am going to post these all up on a GitHub gist so that you can have access to them. So first, I'm going to start with our most basic example. So right here we have a string, and now this string contains a list, and I'm purposefully doing it like this so that we can actually have something that is easy to convert into an array. So right here I have a string. First word is Star Wars, followed by Luke, followed by Darth, followed by Yoda. Now, if I simply want to convert this to an array, I can call the variable, then call the method split on it, and split has a couple different things you can push into it. First, you could push a regular string. So I could get rid of these items and you pass a regular string to it. Usually what I'll do is what I did right here, which is use a regular expression, just because I think it's a little bit more exact and it gives me more flexibility with the things I can push in. So now if I run this, it's going to print out Star Wars, Luke, Darth, and Yoda. But notice that now this is an array. So, and you can even test this out by printing it out to what class it is. And sorry if I did that kind of quick. I just called the class method on this, and what that does is when you call this on an object, it will tell you what class it belongs to. And just so you can see that there's no magic going on here, if I do string and class, just like this, you'll see the first one is of data type string and the second one is of data type array. So right here, it's pretty basic. We took a string, we converted it into an array by using the split method. Now this is something that's really helpful if you remember a couple weeks ago when Braden gave you the assignment to create the reverse method from scratch. The first thing that popped into my head when I heard that was to use split. So if you use split, that's a perfect situation for it, where you split all the elements in the string into array elements, and then you simply iterate over them backwards. So you can dump them into another array that's called something like reversed array, iterate over them backwards, and then you've created the reverse method in only a few lines of code. So split's great for doing things like that. Now I want to move on to another kind of extension of this, and I'm going to comment these both out just so we don't have a lot of confusing output here. But split takes some additional arguments. So split's actually a pretty flexible, it has a flexible interface. And so what we can do here is if we pass the element 2 as an argument, and as we pass it in as a second argument, it is going to actually break the array into 2 pieces instead of into each one separated by a comma. So I'm going to take our output here so we can keep track of what is what. So this one gave us 4 elements. You can see they're separated by strings just like this. Now if we pass 2 in and we run this code, now you can see this looks kind of like it's the same. But if you actually print it out and compare it with the other one, notice here where now we only have 2 elements. We have Star Wars, and then Luke, Darth, and Yoda are actually all in their own element. So if you were to do something like this and run count on this, you can see there are only 2 elements compared with if you did the same thing here. You can see the top one has 4 elements, the second one has 2. So that's just kind of a handy way of being able to use the split method, and instead of having to grab all of them and separate them all out, you actually have the ability to kind of pick and choose how many elements you want split to return. Now the third one, I saved the really cool one for last, at least for our base case example. And that is we have the ability to use a splat type. It's not a splat argument, obviously, because this isn't an argument, but we have the ability here to take a string just like our string here, and then separate it into multiple components, the first of which is going to be the first element. And then the second, when we use this little asterisk, and if you remember back to our discussion on method arguments in Ruby, you can reference it if you don't remember it, but this looks like a splat argument. And anytime in Ruby you see the asterisk right next to another, like a word or variable or something, it usually means that this is going to take care of an array, or it has something to do with a collection, and that's exactly what it is here. So what this is going to do is string is going to output its normal value, but when it sees two items on the left-hand side, it's going to give the very first item to the first variable. And just because I said first doesn't mean anything. I could call this X. It's just a variable name. But this is going to take the first one, and then when you pass in an asterisk with another variable name, split is going to return all the rest of them. So it may seem very similar to what we did with 2 here, but it's slightly different because 2 is just kind of a secondary argument, where here we are literally splitting this into 2 variables, whereas before we were splitting, as you can see, we split an array into 2 elements. Here we are actually giving them to 2 variables. So a good example of this would be, say that you are calling an array, you're calling an API, and you know that just by looking at what you've got returned before, you know that the first word is like the title or something, and then the rest are all the information that you want. So what this is going to give you the ability to do is to store the first one separately from all the rest. So now if we save and run this code, you can see that we have 2 items. And the first one isn't even an array. It gives you the element itself. So let's test this out and see what class these are. You can see the first one it gave us is of type string. So it gave us the element itself, whereas the second one is an array. So that's a pretty cool thing, and that's something that I've used this in a few applications. It's not something you're going to probably do on a day in, day out basis, but it's nice to know that you can split it up like that. One last example for split, and it's not going to be with our Star Wars. I wanted to give you something a little bit more real world and practical. And one thing that you may or may not seen, especially when you've used things like carrier wave or different API return values, you may have seen some really weird items returned back in an API. So there are times where you'll see like an @ symbol followed by an equals, and you get some kind of weird content like this back from an API. And especially if you've worked or if you have to work with older APIs, then it's pretty common to get some weird stuff sent back to you. So what you can do is you can actually use split to take care of this if you have some abnormal values coming in from an API. So what I did is I called the API, called the split method, and then from there I said anytime in this regular expression, anytime you run into this value, I want you to create another array element. So you can see that this array has posts and it has comments, and if I run this, you can see that this generates an array for us, and it's a little bit easier to manage. We'd have to perfect our regular expression to do things like get rid of the empty spaces and things like that. But you can see that our second element here is our full list of posts, and the next one is comments. So that's just kind of one way that you can use split on a more practical basis. So now before I go on to join, are there any questions on split? Sounds good. Okay, so now that we have split, let's talk about its kind of opposite cousin, join. So here I am going to do something. There's a really cool method in very cool method in Rails called two-sentence, and in this lecture, in this walkthrough, we're going to actually recreate it, and so we'll save that for later. But first, let's talk about the basic syntax. I mentioned earlier that join by itself has a pretty limited set of what you can pass to it. So essentially what it does is it takes in an array of elements and then it can convert that into a string. And the one argument that join does take in is whatever you want to separate it with. So say we have Star Wars, Luke, Darth, and Yoda all set up as an array of elements. If we want to turn that into a sentence, or I should say if we want to turn it into a string, then we call the array, we call the word join for the method, and then we pass in the argument whatever we want to separate in the middle of it. So if I run this, you can see this returns Star Wars, Luke, Darth, and Yoda, but it gets returned as a string. Okay, so that's nice, and you can also do something like, say this was going to be a URL or something like that, and you wanted to separate it with dashes. I can get rid of the space, put in a dash, and now if I run this code, you can see that it puts a dash in on every separator, and that's pretty common. The way that I'll usually use join is I use it pretty commonly whenever I am working with CSV files. So if I need to output a file and need to have it delimited by a comma, then join is a great way of doing that. And there are a number of times where you have a number of items just like this that come in as an array, and you want the ability to convert those into a string. So join is something that I do use pretty regularly. But now let's do a fun one. I'm gonna separate this out. So there is a pretty powerful method in Rails called two-sentence, and what it does is it can take an array of elements, and I need to use our array here, and it will actually, at the very end, it will convert the last one so that it gets read as a sentence. So it's meant to take in an array of elements, and then when you call two-sentence on it, it'll convert that array, and it'll add it adds commas, and then at the very end it adds a and, so that it can be read as a sentence. And this one I'm going to do in reverse. I'm actually going to show you what this does. And this is not the real two-sentence. This is just what I created. So this was just kind of me recreating it. And so let's see what this does when we run it in the terminal. You can see that this outputs a string that says Star Wars, Luke, Darth, and Yoda. So this makes our list sound more like a sentence without having to mess with all the elements inside of the array and that kind of thing. Oh, and Nicole, I just saw your question, and reduce, we're actually going to be covering that on Thursday in the lectures this week. I have map and each along with join and split today, and then on Thursday I have inject and reduce fall, and included with that we're going to work on debugging with pry and bybug and some things like that. So I can tell you really quick, just based off of what this is doing right here. So for this code, I'll open up an IRB deal here. So right here, what we're doing is first we are creating a range. So and let's take it one at a time. So we're creating a range, converting it to an array. So we have an array, which you already knew that part. And then from there, I believe it was just reduce, followed by, just LCM. Okay, so what this is going to do is LCM, it stands for least common multiple, and it's included in the Ruby core math library. So this is going to take all of the elements and it's going to find whatever the least common multiple of all of these are, which would be a pretty challenging task to do manually, but the least common multiple algorithm does all the work for us. So really all reduce is doing is it's keeping track of the item. So you could also, just so you know, inject and reduce are the same thing. So they're reduce. I always forget. I think inject is aliased for reduce or vice versa. So inject is very similar to map, and reduce and inject are the same thing. So inject and reduce are very similar to map, which we're going to talk about later today. And what the only difference is that they actually keep track of the item that they're iterating through. They keep track of what the total is, or they keep track of kind of like a running total. And inject and reduce can be a little bit more complicated, so I'm glad you brought that up, because I'll use this as our example on Thursday, and we can walk through line by line everything that it's doing. And the thing that I find the most helpful is to actually build this from scratch so that it's a little bit more expressive on what's going on with it. But yeah, we'll definitely go through that. Okay, so we ran this for the sentence join. And so what sentence join is doing is it takes in an array as an argument. And so this array is getting called inside of the method. And here, all it's doing, this is the way that you can access elements inside of an array. So this is saying that go inside this array and pull out the very last items, or all the items to the very last one. Leave out the very last one, because that's what this -2 does. And let me kind of show you the way this one works. Oh, and you're welcome. So here, if we set this up as an array, if you remember, in order to grab an element, so to grab the very first element, we'd say array and then pass in 0 in brackets for the argument. Now, if we want to bring in the very last item, this is actually possible by going backwards. So if I do -1, instead of being here, and instead of it saying, oh no, -1 exists, Ruby's actually smart enough to go all the way back and go to the very front of the array, and so -1 can be grabbed and it's equal to the last element. So what we're doing in this very first line right here is we're saying I want you to grab the very first element, or the 0th element, and then ... means that we want a range. So I want the first element all the way to the second to the last element. So if we come back here, so first element's here. If we go backwards, we know -1 is here, -2 is here. So what this allows us to do is bring me all the elements all the way from the beginning to the second to the last one. Then we call join on it, and we put a comma right in between each one of these items. So we're passing the comma into join. And then, so this is bringing us, if we break this down on what exactly it's doing, this is going to bring us these items. But it's going to bring them as strings, because it's bringing each one of these and it's calling join on it. So what you're going to end up with is this right here. And then we're simply adding on the rest of it. So we're going to tack on the word and, so we can combine these just like this. And then at the very end, we're tacking on the very last element. And I already showed you how you can go grab the last element by saying array bracket syntax
and -1. You could also, if you wanted to get cute with it, you could go array last and this would do the exact same thing. Because remember, Ruby has some cool things when it comes to being able to grab the last element and the first element and that kind of thing. So that is a way where you can recreate the two-sentence one. This one doesn't take into account some of the kind of debugging things you need to do, like you'd need to make sure that you protect if someone tries to use this on a word that has one item, because then these lookups would break and then you'd get a weird error even if they called it on an array. So you'd have to have some things that caught that, but for the majority of sentences this would work and it would make it sound like a real English sentence. Okay, so now are there any questions on join? Sure. And Braden, do you want this to be reversing a string like we already did, or do you want to do the, are you talking about reversing the words or reversing the letters like we did a couple weeks ago? Cool. Okay, couple different ways to do this, and there is a I think I shared it. There is a character method where you can call that and you can simply iterate backwards on all the characters, but don't, that's kind of defeating the purpose because we're trying to learn about split and join here. So I'm going to just take a word. So I'm going to say my word and we'll just say hello. Nice and easy. Okay, so you know that we have the reverse of this. So if I print this out, this gives me hello backwards. So what we're shooting for is the ability to do this. Now when I saw that this was one of your guys' challenges, I thought that was a really cool one because it's a good test to see how well you can work with those items, because it's going to take it's going to take knowledge of both of those, of split and join, to get this to work. So I'm going to get rid of this, and very first thing that I would do is I can create something that says reversed words and set this equal to an empty array. And then from there I can say my word split, and in order to get an element split out completely with, and before we've passed in a comma and things like that, if I put in 2 dashes, then that will break up an item into where every single character is an element. So let's just test this out to make sure this is working. And you can see here we have an array called hello, and each element is a string. So in order, now that we have that, we know that we could just iterate over this. So I can do each, do, and this, put L as the block for letter, and then let's see the best way to do this. Oop. Okay, so there's a few ways we could do it. I'm trying to think of which one would be the opposite. I came up with a really elegant solution. You caught me off guard in asking for this one, because I did research this one and found a pretty cool way of doing it and swapping the letters out. But let me I forget if I did the reverse each, because this I'm pretty sure would work, but let me take a quick look at it. Let's see. Okay, so that's one way of doing it. This would probably be the easy way. I'm not sure if that counts as breaking the rules or not, but reverse each actually is an iterator where you can reverse through an array. So we have my word, we split it into an array of characters, and then reverse each is a method where it iterates over a collection backwards. And then inside of the each block, then I took the reversed words array, and then I simply added each element in going backwards, and then printed out reversed words. And then to finish it off, then all we have to do is we can just say join, and now we have hello. And if you wanted to wrap all of this into a method, then you can do that pretty easily, where we'll say def my reverse, which takes in a string, and now we have, let's see, each spot where it took that string in. Okay. Now we're going to call my reverse on my word. And let's print it up. There we go. Okay, so if, say that someone asked me in like a coding interview or something like that to recreate reverse from scratch, this is one way of doing it. There's actually, it brings up an interesting topic where we can play around with this when we talk about using map. I should have thought about this one. This might be a really good fit for map as well. I'm not sure if there's a reverse map or not. But that's a way that I would do it just right off the cuff. And so that's using split here to convert it into an array of characters, and then using join to merge them back into a string, just like this. Gotcha. Yep. The using -1 index. I think that is actually the one where I think that's what I did when I sent you my solution a couple weeks ago. That's what I played with, was going backwards through that. So let's play around with that really quick. I'm going to get rid of this call, and I'm going to not add this at the moment. So let's take a look at what L gives us right here. So if I run P and L, this gives us this set of characters right here, which we already knew about. So that gives it to us, but it gives us to us in a a regular array item, or a regular string, just because we're printing it out with each iteration. It's not in a collection. But if we do something like, let's see, we do L, and then we're going to add in a negative value for each one. So we're going to do our reverse words array here, and then put in -1, set it equal, and let's see. Oh, my reverse. Okay, so, oh yeah, the very first one that's going to throw an error on. I have to play with that one a little bit and see. I forget what I had sent over, because I really did like the example that I sent you last time. So let me see if I have that. Yes, here we go. This is better. This is the way I like doing it. Okay, so this is alternate reverse. So the first thing I did here was I converted it into an array of items. Then I did the same thing. Both of these were the same. Then I created a total count of items. So I created this was what I was missing, is I needed a total count, so I knew exactly how long the array would be. And then I created a total count. Then I did the down 2 method, so it would go down to 1, and then I iterated over dumping it into the reversed array, and I took the string array with I minus 1. So here it all went backwards. So now if I save this one and run this one, it probably would help to print it out. There you go. And then that runs it through backwards. And so this is a better way of doing it. I like this one because I think I came up with the first example first, but I thought reverse each was cheating. It gives us the same exact thing in a coding interview or something. It'd be perfectly fine to do that one, and they may even be impressed that you know what reverse each is, because most people don't use that. But this is probably the more standard way, especially if you're interviewing someone from a different programming language, because this is the same way that would work in Java or in C or any other language like that, where you're using the string array, grabbing and dumping the last element in and doing it backwards. So this is combining join, split, and then here I combined down 2, and that's how I was able to iterate backwards on that. All of that to say, if you really wanted to do it, this would be the easiest way, because you can do all of that in a single line of code by using the cars method here. So cars is going to actually grab all the characters in a string, then calling reduce, and then iterating through that and simply adding them backwards. So going B plus A. So if you actually remembered the syntax, then that would be a pretty cool way of doing it. But either of the 3 ways we talked about, they'd all be considered fine. Okay, any last questions on that before we move on to map?
Okay, so now let's talk about map and each. Now these are both enumerable methods, which means that they're used for iterating over collections. Now these ones, these took me a little while, so I'm glad that we can dive into them a little bit deeper. So here we have map, and here we have each. If you are just looking at the kind of the surface level of them, they seem almost identical in the sense that you can take collections. So you can take some type of collection here, and you can also take a collection here. Both of these are exactly the same. Next, you iterate over the collection. So both of these, you're going to iterate over. Same thing on both of them. Now, the difference is all in the return value. This is where they're not the same, and this is the most important part of it, and it's also something, it's one trend I've seen that's really interesting is the more advanced the Ruby developer, the more that you see the map method used in their code. Each is easier to understand, and it's used extensively, especially in Rails. And the way that I usually like to think of it is each is something that should be used when items have to be seen, and map is something where you're actually changing the structure of a collection. And so I have a couple of code examples we'll talk about on how those work. But that's the biggest thing I want to stress is the difference is all in the items that are returned. Nothing is returned in each. Map actually returns whatever changes you made when you were looping through the collection.
So here I have a couple examples that I prepared for us. Give us some more space. Okay, so here I have a few projects. So I want to pretend that these were for, like say a project management site, and I was because this is something that I do for all my upcoming courses. I put them up in a project management site where I can add details to them, and I can see them all there and make comments and save links, that kind of thing. So here I have projects, and if I want to simply iterate over projects and show them on the screen, then each is very good for that. So that each is perfectly fine for if I want to, let me just kind of comment all these out. So if all I want to do is print these to the screen, I can do projects, each do project, and then just run a put statement for project. And now if I run this code, this prints out all my projects. And you've done that a million times. Each is what you use in your Rails view code, and it works fantastic. And that's what should be used. You shouldn't use map or anything else in your view code, because remember, its goal is to render items and to iterate over items, but not to really change their structure. So I'm going to get rid of this, and I'm going to talk about some other case studies. So say what happens if we have a view helper method. And this is something that does come up quite a bit, where you want to have something where you apply a style to a collection of items. In this case, I'm going to do a very basic one, which is just to make all of the project titles uppercase. Now let's ignore the map example right now, and let's talk about how we can do this with each first. Because if I comment out uppercase projects right here, so if I just created this uppercase projects, set it to an array, or even let's even bypass that. Let's just say that we have our projects, we iterate over with each, and then we call upcase on each one. Now, if I come here and I call this method and I pass my projects in, you can see that it simply prints out the regular array that has been completely untouched. So even though we iterated over these and we called upcase on every item, all this happened in the background, our method wasn't really that helpful because it didn't return back our styled projects. So what we'd have to do with each is, I don't want that uncommented yet. There we go. So what we'd have to do with each is we'd have to do something to be able to keep track of our elements. So here we have uppercase projects, and we create this array. It's empty in the beginning, and then as we iterate over projects, we save our styled or our uppercase project inside of our new array, and then at the very end we call uppercase projects. Now if I run this code, you can see that now we have the behavior that we're looking for. So we're able to create an array, dump all the items that had actually been changed into it, and then we return the value. So everything works here, and this is perfectly valid code. However, Ruby has a much better way of doing it, and that is to use map. And this is where map really shines. And see how before we had 1, 2, 3, 4, 5 lines of code. We can actually use map to do the exact same thing. And in fact, we could technically even have map do the same thing in a single line of code, because the syntax is so much shorter. So we were able to take 5 lines of code, take it down to 1, and now let's see what happens. Now you can see that our second map call, or our second enumerable call here with map, it has the identical behavior as everything that we did up here. So we didn't have to create a new array. We didn't have to dump the items into the array, and we didn't have to return that array. Instead, what map does for us is it actually gives us the return value completely for free. So it keeps track of all the items, it makes it the changes, and then it returns them. And so this is where map can just destroy each from a performance point of view, and also just from a kind of a code readability standpoint, because it's always better to write a single line of code like this, assuming it's explicit and you're not writing some weird metaprogramming kind of things. But from a high level standpoint, you have a very easy to read map call right here. It's simply iterating over a collection. It's calling upcase on it, but the most important thing is, because this is the last thing returned from the array, this actually, or from the method, this is going to return the full array, but all the items will have been converted to whatever style we want. Obviously, uppercase isn't that big of a deal, but it's a say that this was in a Rails application and you wanted to change the styles on them and add a CSS class or something like that. The map method could take that collection in, add all those styles, and then return them on a single line of code, or just a couple lines of code, whereas each would just take a lot more. My main focus on creating this comparison here is, one, to show you that there are multiple ways to accomplish very similar behavior in Ruby. So Ruby is not that opinionated when it comes to solutions. So you have the ability to create many different kinds of solutions in order to create the right kind of code, but sometimes one option is considered more of a best practice. And what that is if you go through your code and you see things like this, where you're creating a standalone variable that's keeping track of values, and then you're returning it at the end, this is considered a Ruby poor practice, because what this means, especially when it's sandwiched in between, or when they sandwich in between an each block. Because what this is a pattern of is, this is the exact reason why map was created, was to be able to make it so you didn't need to create pointless variables and force return items. You can simply iterate over, make your changes, and then you'll be good to go. Now remember also, map does have the ampersand syntax, so I could shorten this even more by getting rid of this and taking project, so I can call this method on it, and this has the exact same behavior. And honestly, in most cases, especially when you're going over Ruby projects that have been built by more experienced developers, this is a syntax you're going to see used with map quite a bit, because a very common pattern for map is to be able to send a method to items in a collection, and that's exactly what you can do with this ampersand syntax. All this is doing is, it's Ruby knowing that in most cases you're going to have some kind of looping mechanism like this, where you have a block, you have a block variable, you have do and end, you're iterating over, and then you're calling a method. Just like we had previously with map. It's such a common pattern using this ampersand syntax, you can bypass all of that. Ruby does all this for you in the background. It gives you the block variable, and then it calls whatever method you have here on that block variable each time, and you still get the cool return value. And this is such a common pattern that there are many times where, even though you may think that, I need a method to put all that behavior in, as you can see, there's really not even a lot of reason why you would need something called, styled projects with map, because you could just come here, call projects dot map uppercase, and you'll see that we get the exact same behavior. So this right here gives us exactly what we got when we had the method, just by calling map and passing in using a block syntax here with the ampersand, passing that in, and that's going to give you the same exact result at the end of the day.
Okay, so I'm glad all that made sense. Message me if you have any questions on it. On Thursday, we're going to talk about inject, reduce, and we're going to combine that with a, yeah, Braden, there's an SD delay, where we're going to combine that with a discussion on how we can use debugging to be a little bit more calculated with our development techniques. But before we go on, or before I end today, the biggest thing I want to talk about, or really want to stress with the whole map in each, and this is not just with map in each, it's actually with a lot of different things, is being smart about picking the tools that you use, because that's really all it comes down to. As you saw, we were able to implement the identical behavior with both options. So there really isn't one right answer to that. One, it's a little bit of an art, so there's some skill built into it, and a lot of it you'll get the more experienced you are with it. But the other big thing is, I like to think of the analogy of having an axe or a chainsaw to cut down a tree. There are a lot of situations where an axe comes in very handy. You have the ability to, chop up small amounts of wood, or you can, do certain things where you don't need the powers of a chainsaw. However, if you're going to chop down a huge tree, you could spend weeks on doing that with an axe, or at least that's probably how long it would take me. But a chainsaw could do it in a couple seconds, and it'd be more efficient and just a smarter way of doing it. That's really the difference between things like this. Between tools like map or like each, it really just comes down to picking the right tool for the right job. So that's the I wanted to end on that, because one of the confusing things when I was initially learning Ruby was I would find all of these different methods and different processes that really seem very similar, and a lot of them are, but what it came down to was there are certain situations where, yes, both of them would work, but one of them is going to be a better fit than the other one. So I'm glad, and like I say, I just got one more post on that. Yes, and Jason, I'm glad. I'm glad that was helpful. It's something that you'll find very handy, because as you start working on fully professional projects and you get out there in the world in development jobs, you're going to run into map in your code all over the place. So it's very good to know first and foremost what it does, but more importantly, know the power of it compared with some of the other options that are out there. So if no one has any questions, then I will see you on Thursday. But as always, feel free to message me if anything comes up in the meantime.